The last new section of this particular part of the unit, we are going to discuss, little vocab here, relations and functions. Like I said, very, very visual. Just got to get used to what we're chatting about. So, a relation, love it when these things have words that are similar. A relation is a relationship, hence where it's getting the word from, between sets of values, sets of numbers. So the two values, we got to have a fancy name for everything in math, are called input, or sometimes they're called our x values, and output, our y values. I stick in, I substitute in an x, I get out a y. So you're actually, whether you understand that you've seen these before or not, you have, because if you had something like y equals 3x plus 7, let x equal 4 and solve it, you input the 4 into the expression, and the output that you get is the y value. That's all it is, okay? Just a fancy way of saying it. And so the difference with a relation that is a function is that that's a special type of relation, we move this out of the way, where each input, each x, only has one output, y. Now, that seems to be logical. If I plug an x value into an equation, I don't expect to get 3 y values out. That'd be kind of weird. But I do expect when I put 1 in, I'm going to get 1 out. So, there are 4 ways that we can try to figure out if a relation is a function or not. So, the first one is going to be using ordered pairs, just coordinate points. So, the x and the y coordinate of a point. Now I look at these and I'm like, okay, all ordered pairs mean is, this is my x, that's the y that comes from it. Plug in x, get y, plug in x, get y. Oh yeah, okay, I get 1 for 1, that kind of makes sense, okay. That's one way I can relate. We're not worrying about the function part quite yet, just making sure we got this. A table that lists all of the inputs and outputs, x and y. These are the exact same thing. They're just written differently. Instead of coordinates, I put them in a chart. Same numbers going in, same numbers coming out. So nothing big there. All 4 of these are going to give you the exact same info. Mapping. This one, for each input and output, we use arrows. So now, all of my input numbers, all of my x's are in one spot. So for like 1, 3, I just draw an arrow from 1 to 3. 2, 1, I just draw an arrow from 2 to 1. But it still is making all of the same connections they did in the first 2. And then finally, we can do it graphically by using a visual display where I plot all of the points. Y is like my output, and x is basically my input values. All 4 of those things say the exact same thing. So you're like, okay, so what? So what is that when we actually start trying to see if there's a function, they each have unique ways of us being able to use them to see if they actually are going to be helpful or not. So here's how this works. So when we're trying to figure out if the relation's a function or not, okay, below are some examples of relations that are not functions. Let's figure out the difference. Okay, so here, ordered pairs, you're like, well, what's 1 for 1? You know, what's the big thing? 2 ways when you're looking at an ordered pair, okay? Number 1, your x values cannot repeat. You're like, well, okay, what's the big deal about that? It's still 1 for 1. But the problem is, okay, one x value, in this case 3, has 2 outputs, 5 and 8. I stick in one number, I get 2 numbers out. That doesn't make sense. It has to be 1 for 1 every time. So the minute you see in ordered pairs, if you see an x value repeat, that's not a function, ever. Okay? So again, and we got it down here, all the x values must be different. Just a different way of saying kind of what I said up above with number 1. Okay? If I have a table, it's no different. If x values repeat, it's a no-no. So ordered pairs, tables, okay? The map can get a little more interesting, because you start to look at it and you're like, well, okay, there's 1 to 1, all right, so this goes to that, that'd be okay. And this goes to this, that'd be okay. And this goes to this, that'd be okay. Here's my problem. This 3 goes to 1 and it goes to 2. One input has 2 outputs. For each one input, there can only be 1 output. So if any of your x values have multiple arrows coming from it, oops, let me move that over a little bit. It's bad. It doesn't work. It's not going to be a function. And so that's really all you're looking for. Everything is about x when we're trying to figure out if something is a function or not. So when we're checking these out, all you're really paying attention to is that. Are they all different? Yep. Bless you. That's a function. That's all you have to do. Well, Hardy, though, there's y's over here that repeat. Doesn't matter. It's still one y value for each x. The other way around for right now doesn't make any difference at all. What about number 2? Is that a function or not? Nope. There's your problem. 2 arrows. Not a function. What about 3? Nope. Doubling up again. It's kind of nice that we only got to pay attention to the x's, though. That does help us a little bit here. This one's clean, man. What about 4? Function. Like literally, that's just as nice as it gets. Straight across, 1 to 1. Everything's working. And so I kind of look, okay, Hardy's going to freeze frame like super fastest ever. Do 5 and 6. Well, I got some speed demons out there. Oh. Now see, these videos I do are supposed to be eligible for kids. I gotta watch that because otherwise, I wonder if they would flag me sometime if that got caught in the background. I guess I'm gonna find out because I'm posting this anyway. Okay. So as we're looking here on number 5, all of my x's are different. I'm good. Y's are all the same. Don't care. It's about the x's. But I have an x repeat there. So when we're looking at these, it's really not going to be that rough to figure this out when it's just numbers. But there's one piece we haven't really looked at yet. That's the last one, and it's even got a nice little deal to it here. Okay, what if I just get a graph? What if I have no numbers? So we're going to use what's called the vertical line test. What direction is that? Up and down or side to side? Up and down. All right, so we're doing the vertical line test here. So find something to use as a straight edge. I have my little Post-it notes here. And so what we're going to do is we're going to start on the left side of the graph, and we're going to slide across, and all I'm looking for as I go here is to see if at any one point my vertical line touches more than one place. If it touches more than one place, it's not a function. So like if I stop here, it's only going through one spot. If I stop here, it's still only going through one spot. Still only going through one spot, and I made it all the way to the side, and we're good. That one's a function. That's okay. But if in any place on the graph, as I start going left to right, I stop and I'm like, uh-oh. 1, 2, 3. Once I went more than one, it's no. It doesn't matter if it's 2, 3, 8, 10, doesn't matter. And it doesn't matter that if I go way over here, well, if hardly way over here, it's only 1. Doesn't matter. Anywhere in that graph you go, if you get more than 1, it's a big to that one. So you'll kind of start getting to see here fairly quickly how easy it is to start figuring this out. Like this one, maybe I don't even think I need this. Is number 1 going to be a function? Yeah, I don't think so. I mean, if I wanted to, I'm like, oop. Nope. What about 2? Are you sure? Are you sure? Are you sure? Okay. 2's a definitive yes. 3, all right, let's check this out. One spot. One spot. Where's my problem spot? The middle. Here? Yeah, when we're talking about the graph, it's only like the picture. The axes do not count as part of your graph. This one's okay. What about 4? The good old-fashioned no yes. It's like when you're doing heads and tails, and you say, heads, tails, and then it's like, yeah, I said that. And you're like, no. Okay. I'm going to pause you. This wasn't going to be math stressful today. Now, I'm going to add one more piece to the puzzle here on the back. So you get back to the FCN stands for function. Why I decided to use FCN. What's that? Oh my gosh, I haven't unfrozen. Okay, thank you. So I get to the back here. And I'm like, all right, let's just deal with function, not function for a minute, and then we'll add the last piece in. So I get here, I start to go, and I'm like, uh-oh. Okay, function, no. What's this domain and range thing? Okay. So domain and range, and we've talked about domain and range on other things before. Domain and range is just your x and y values of your graph. Yeah. I just decided, I put my vertical line through here, and I saw, for instance, I didn't think about an exact value. I just noticed that it goes through my graph right here, and it goes through my graph right here. And as long as it's going through 2 spots in a vertical line, yeah, it wouldn't matter if I did it over here, it will not make a difference. All right. When we're doing domain, we're looking for the farthest left point of our graph. So about here. What's the numbers that look like? About what? Negative 4.5. Okay, let's do a little labeling here. Okay. Normally they'll be at whole numbers. This one is weird. And there we go. As far as we can to the right, what value is it about there? About 7. So when we do domain, and I don't care if you use parentheses or brackets. I'm not going to get that picky. I will use the same one, though. We're just trying to describe to somebody who's looking at this, hey, what's the furthest point to the left? What's the furthest point to the right within my graph? Okay, it'll always be the same direction with those. The y for my range is doing y values from bottom to top. And again, we've done this with a couple of other graphs before, even just plain old lines. So I'm looking for the bottom, and sometimes it's kind of tricky to tell where it is. So we kind of guesstimate where it's at. That looks pretty close to the bottom. So it looks like I'm down at about -2. And then I go as high as about here. And again, for almost all of yours, they're going to be whole numbers. But if you guess 1.9, 1.5, I'm not going to jump up and down and yell. I'm just looking to see, are we seeing the idea of how this works? Because as we play with a couple extras here, is this one going to be a function? Looks like it, because everywhere I go, I'm only going through 1 point. So, okay, this looks like a yeser. Now, domain, here's where I got to watch out. And we've chatted about this before, too. Whenever you see arrows, arrows always equal infinities. So if I see that arrow going forever to the left for my x's, that's heading to -infinity. It's going forever to the left. Like this just keeps going. It doesn't stop at that arrow. It just keeps on going forever. Now, furthest to the right, it's another arrow that's going forever to the right. This happens quite often. So I'll kind of give you a heads up. But range, though, ooh, careful with range. Because this is y now. Here's the bottom of my graph. What's the y value at that point? 0. If I go back to the origin, it starts at 0, but it goes up forever. So most of the time you get arrows, almost everything is going to be infinities. So let's throw in a small twist. So I want to make sure we got examples of everything, because that's always a big deal to me. Number 6 is weird. Number 7 is also going to be weird. We're going to do 6, 7, and 8. Then we're going to be good. There should have been a little dot here, but it was not there. Notice a dot, not an arrow. So if I do my domain again, x from left to right, here's my furthest point left. Okay, the x value is -5. Follow it right back to the x-axis. But then it goes forever. This is going up and to the right. Arrows, we're going to get infinities somewhere. It happens every time. Range, same point. This is the bottom. But I'm following it back to the y-axis. Starting at the bottom at -3 and up forever. And we already said this was a function. So I don't think the function thing is going to be a big deal. It normally isn't. It's the domain and range stuff that gets a little kooky. So I kind of go through here and I'm like, hey, Hardy, like, is that going through at multiple places? Like, that's the only place I can really tell. It looks like it is. If you wrote yes on this, I wouldn't yell. Okay, because that's close. Probably shouldn't have one that close if I'm going to do these. But my domain, again, left. Here we are at the furthest left again, somewhere in here. If you went to the nearest hole, if you called that -7, I'm not going to tell you you're wrong. Nearest whole number is not a bad thing. Right side, arrow. Arrows are infinities. Every time. Left to right, rocking and rolling. Range. Now, that's not my lowest point. You're like, wait, they don't have to be the same point? No, no. This is lower. Right here. And again, if you guesstimate, I don't know, -6.5 -7. Up forever. So x left to right, y bottom to top. One last one. Hardy, you're not. Oh, I am. I'm going to go freeze frame on you on number 8. I won't leave you hanging. That I will help out with the domain and range, but kind of try it. Look at the last couple we've done and see if you can figure out where we're going to start and stop on those. Sure. You're going to have lots of infinity. I will warn you of that. That is truly a thing on this. We will unfreeze here in about 10, kind of let you see where you're at, what it might be. At the very least, make sure you've got if it's a function or not. So make sure that we're in good shape here. All right, let's give this a run. Maybe. There we go. That's okay. That's fine. Domain, we are going forever to the left. So my furthest point left would be at -infinity. On the right, if you said, now, if you're saying 3.5, you might have been looking at y instead. Or you might have been looking here and said 3.5. Either way, you're all right. And we've got that. And then range, though, down forever to -infinity. Up forever to +infinity. Yeah, that one we got to get the infinities with the arrows. If you had a dot, we'd be okay with either of those. So that might be the trickiest thing we play with today, is kind of dealing with that. So, okay, here's the bottom line. That's the end of the notes. Whoop, whoop. Okay, there was one thing I did not put in the notes that I will say one thing about here in a moment. So I left myself a note. Okay, so determine if it's a function or not. You're like, wait, is that all we got to do? For some of it. Okay, on 11, is it a function or not? Okay. 12, oh, Hardy, man. Okay. When you get back here, you determine if it's a function or not. Then we're going to do domain and range. Now, I need to say a couple of things back here. Okay? There is a difference between when you have all the points connected, like let's say they are number 4 or number 5 and number 6, versus when you're doing your domain or range and they're not connected. You're like, what the heck, dude? Okay. So I still can test pretty easy to see if it's a function or not. I only see one dot each time. Okay, it's a function. That's cool. But what about domain and range? There's no arrows, so there ain't no infinities. So what we're going to do if it's just dots, you're going to make what's called a brace. It looks like somebody drawing a silhouette of somebody with a really big forehead and chin and a pointy nose. Okay? That's what happens when they're individual points. So we're just going to list the x values of every single point that we see. So all I did was I listed all the x's. No parentheses, no brackets, just the little squiggly brace there. And I'm going to do the exact same thing for my range when they're just individual points. Bottom to top. So lowest y value is at -2. Then we make it up to 1. And then both of these are at 3. I don't have to put that twice. So if you have a problem like number 1 or number 12 where they're individual points, you just list them that way, okay? Everything else that you see on here is going to be like what we had. Whether it's numbers, but it'll all be interval notation like we did in the notes except those two. Every other one, we figure out the function, we try to play with domain and range. No, you're like, Hardy, you're still coming? I'm still coming, because we're going to turn this into odds or evens. So just stick with me. I'm not powering you through all of these. Hardy, what the heck is going on back here? Fill in a table of values for each function, graph the function, state the domain and range. If you want to graph the line without doing the table, you could. But otherwise, it's not hard. I mean, we're just going to 3 times 2, 3 times 1, 3 times 0, 3 times -1, 3 times -2. These are all just coordinate points. So if I plot each of those, I should end up with a line. If I don't, I did something wrong somewhere. Okay, so there's my line. All the dots are connected. These are all going to be functions. You don't have to figure that part out. So domain. Left, still going left. Arrows are infinities. To right, that's still I know it's going up, but it's also going to the right. Infinite domain. Range, bottom. Oh, no, that's also the bottom. Bottom to top. Oh, we're going up for... Dang, are it can be like all infinities? It can. And it is in this case. So a good thing to figure out. But the one thing we did not chat in the notes that I'm going to do very quickly, just with a couple of examples to make us sure we're good. At the very beginning of the lesson, I talked about when you plug in like y for something, y equals 3x plus 7, let x equal 4. That's what this is. All you're doing down here is you're taking this number in parentheses and you're literally plugging it in for x. So this is just 6 times 4. So f of 4 would be 24. I'm not solving anything. We're not dividing by 4. We're not trying to get f alone. We're literally just plugging the number in parentheses in and going about our business. So like here, if I plug that in, whenever we're substituting, parentheses is a must, especially if we're squaring numbers. Because -3 squared, let me show you something quick. I think we've talked about this before. So there's what I should get. I should get 9. If you don't use the parentheses, you're going to get -9. That's not right. So whenever you're substituting, use the parentheses to play it safe. Just saying. I think... Nope, we're not to that until tomorrow. Okay, so that gets us to the end of all of this. So again, bare minimum, we're looking for odds or evens and making sure your work is good. Would it do you better, since this is new, to probably do them all to make sure that you have enough review before the quiz Wednesday? Probably, but that's your call. So I've got a key up here. If you want to be able to check answers as you go,